All right, welcome everybody to our next edition of the Desert Skies Virtual Star Party. I am Jim Knoll from the Tucson Amateur Astronomy Association, and we are coming to you live from Tucson, Arizona. We have some high, thin clouds here, so we're keeping our fingers crossed that they don't get any heavier. But we'll do our best to show you guys some cool objects, and we'll do a little astronomy. So let me just kind of tell you a little bit about what we've got going on here. So we have 3 telescopes connected up to our feed. Rick Paul is streaming his, and then we have Bernie Stinger and Jim O'Connor. And so we'll have those 3. And then my wife, Susan, is monitoring the chat. So if you have an object you want us to look at, or if you have any questions or something like that, bring it up on the chat. She'll get them to me and we'll do our best to answer it. Before we get started, I did want to tell you that our next virtual star party after this one, assuming we can get this one in and not have to cancel it because of weather, will be February 10th of next year. And we'll run that one from 7 to 9. So let me stop this and we will go ahead and get started. So Rick, I'm going to turn it over to you, and why don't you show your first object and tell us what you got. We're not hearing you yet, Rick.
Got your mic on, Rick?
There we go. Sorry.
That's all right.
So what we have here is called the Veil Nebula. It gets that name from its lacy structure that you see from all these clouds. You're seeing it here. There's some through here. You can kind of see then more through here and more down there. And what you're actually looking at is the remnants of a very old supernova. So if you imagine, you're seeing an explosion, you're kind of seeing the shock waves that came off of that supernova. And it's happened a very long time ago, because these things are very far apart now, all of this structure. And each one of these has kind of been given its own name. This little piece down here kind of looks like a crooked broom. So it's called the witch's broom. This is located up in the what's called the Great Cygnus Loop up in the constellation Cygnus. And it's a very pretty thing to see. It's not really visible to the naked eye or with a visual telescope through an eyepiece. It's a very dim object. It takes a very large telescope or long exposures to be able to see it. Jim, do you want to show everyone where this is in the night sky?
Sure. So I will show you. We're using Stellarium, which is a free program that you can download to your computer. So if you guys want to check it out sometime, just go to Stellarium, STELLARIUM, I think, .org. So this is where it's at. It's in Cygnus the Swan. It's out here by the Swan's right wing, and that's where it's located in the night sky. So right now it's actually pretty high up. It's practically straight up. So that's where we're looking, and yeah, it's like Rick said, it's really, really hard to see visually. You really do need to have a camera to be able to see it. And you'll hear us talk about this throughout the evening, but typically our eyes don't see that well at night. So our cones, which is our daytime viewing, can see color and can see everything really, really good during the day. But at night, we need to use our peripheral vision, which is where our rods are, And so that's why a lot of times when we have people come into the telescope, we tell them, hey, you know, when you're trying to look at a dim object, you want to use your peripheral vision. You look off to one side or the other in the eyepiece, and you look back at the object out of the corner of your eye. And that's to get the rods going so that you're able to see these fainter objects. But with a camera, we don't have that problem. We can see those faint objects much better, and we can see them in color. So this is that's going to be a really good benefit. So yeah, so this is where it's at. It's pretty much straight up in Cygnus the Swan. When you look up in the night sky, you'll see what kind of, it's also called the Northern Cross. It'll look like a little cross, but the long part is really the neck of the swan, and then the head of the swan is out here is a double star called Alberio, and then the tail is back here. This is a star called Deneb. All right, Rick, anything else on yours?
Nope, I'm good, unless there's any questions.
All right, Bernie, how about why don't you go ahead and take over?
All right, sounds good.
And while Bernie's starting to share up, I just wanted to let you know that we're going to each one will show an object, and then when we start the round two, we're going to start off with a picture of the scope they're using, just so that you have an idea of what kind of setup they have, and they can talk about it a little bit.
And you're going to see a ghostly image of my face here. That isn't because I'm still practicing Halloween. It's because I'm out in the dark with a very faint light shining on me. So let me see if I can get this to share. And all right, it should do it. Okay. Bear with me a moment. It looks like my program decided to go out on me, so I'm going to bring it back up again. Bear with me. And there it is. Okay. Sometimes this works better than others.
Picture doesn't want to go away tonight, huh?
Yeah, it doesn't want to drag off like it did before. I'm not sure exactly why. Oh, there, I got it.
There it goes.
Okay, so what you're looking at, I'm assuming you can see this. That kind of ghostly reddish circle just to the right of center is called the Helix Nebula. It's in the constellation Aquarius, which is tonight kind of just east of due south at roughly 40 degrees altitude. So it's down a ways, but easily accessible here from Tucson. The Helix Nebula is also called NGC 7293, which is the new general catalog designation. This is a planetary nebula, and it's very faint. It has a magnitude of 7.3 on the magnitude scale, which is usually that magnitude level is typically more common with things that are brighter. However, because it's so spread out, it's diffuse and difficult to see yet. Can you make it out? I'm hoping you can still see it there, guys.
I've got it.
Yeah,
Bernie.
yeah, we can see it. It's pretty faint, but we can see it.
Yeah, okay. I can't tell from going through the system whether it's coming through clearly or not. So the Helix Nebula is actually named because in images that are brighter with much larger telescopes than mine. It has kind of a spiral shape to it, like a spring. And you can kind of see that spring appearance starting on the far left center, kind of spiraling around to the right, then back up again, and then ending over to the far right. Now, it has a reddish glow to it, you'll notice, and that's because that is ionized hydrogen gas that was thrown off by the central star that's right at the middle of the circle there. So that kind of fainter, smaller central star there is the star that exploded some thousands of years ago. And what you're looking at is the explosion from that star radiating out into space. And the outermost shell of that star was most commonly hydrogen. So that hydrogen gas is now radiating out into space, and it's being ionized and glowing red by the star that threw it off. Now, that central star is in its last period of its lifetime. And it will eventually become a white dwarf, and you won't be able to see it any longer. Of course, I don't think any of us will live that long to see that happen, but that's how it will end up in the distant future. This nebula is about 655 light years distant, which places it kind of in our neighborhood of the Milky Way galaxy. It's not a direct neighbor, but it's down the street a ways. It's been measured at about 3 light years wide. That whole nebula from left to right is about 3 light years across, which is almost the distance from our sun to the nearest star, Alpha Centauri. So that's a huge, huge nebula. It's spread over a huge area. And it's estimated to be about 10,000 years old. It was discovered by Carl Harding back in 1824, which is kind of a late discovery for an object of this magnitude, but because it's so dim, it was overlooked by many, many astronomers for many years until 1824 when he discovered it. And that's the Helix Nebula.
Yeah, that's really nice. And that one is definitely hard to see visually. You need some camera capability to be able to see that. Sarah asked on YouTube if Unistellar was an app that you can use to view stuff. And Sarah, when we go over Bernie's telescope here in the next round of objects, it'll become a little bit clearer as to what the Unistellar is. It's actually
and I'll explain
Bernie's
some
telescope.
of that. Yeah, I'll explain some of that.
All right.
Yeah, this object, you would not want to keep finding this object with binoculars. It probably wouldn't be possible.
Yeah. And I'll just show real quick where this is in the night sky. So it's down in Aquarius. So as Bernie mentioned, it's pretty far south. And that's the Helix Nebula. All right, Jim, are you ready to go for your first object?
Yeah, we'll give it a shot. Let's see. And well, there it is. That little tasty object is called M56, a globular cluster. globular clusters are sort of retirement homes for stars. There's about 100, between 150 and 160 of them circling the core of the Milky Way, or in the outer halo of the Milky Way, rather. And it's always been a mystery as to where they had come from because of their age. The main body of the Milky Way is about 7.5 billion years old. But these objects are over 10 to 12 billion or more years old. So what's the deal with them? So they were studied for a while. And what was determined was that in a few of them, they could detect an intermediate mass black hole. So it's anywhere between 100 and 100,000 times the mass of the sun is the effective center of that object. And the only fingerprint they could think that is of an old small galaxy. So it looks like when the Milky Way was formed, there were a lot of smaller galaxies around it that were formed not long after the beginning of the universe, and they were kind of aging out. And so therefore, at 12 billion years, these stars are old ones because the other ones would have all either burned out or gone supernova. So all you've got left is about average or smaller than average sized stars clustering around. So the clue is that most of these globulars are probably the cores of old galaxies, or they could have been the same age and be back around the start of the universe when there were big hydrogen gas clouds around and no other pollution in there, no other debris from other supernovas or anything, and the whole gas cloud started to collapse and would form lots of stars. And the stars were so many in such a small place that they held together by their own gravity. They didn't go off wandering on their own. So that's a couple of different ways that a globular cluster could be formed. In the case of this one, this globular cluster is in the constellation Lyra. And that's kind of nearby where you saw the Veil Nebula. But this is a little bit under it. And it's in a very populated part of the galaxy. We're looking right into an arm of the galaxy. So you see lots of eye candy in there. This guy, M56, is, as I said, nearly as old as our universe, but about as busy as a beehive. All the stars in there are really moving around a lot. Their density and their mass hold them together. The individual star sizes are pretty small to have lived this long. And once in a while, when the stars go through a planetary nebula state, when they get old enough that they can't support themselves by gravity anymore and sneeze off their outer layers, like the helix was, that was the outer layer of a star that kind of went away when it kind of ran out of extra hydrogen to get nuclear fusion to hold it up. So they're running away. That's left behind that white dwarf. And the white dwarfs are spinning around. They've got no solar wind to protect themselves. So they can collide. They're so close together. And when those white dwarfs collide, they rip the nuclear material apart that's in there, and they form a thing called a blue straggler. It's blue because it's hot and new. So that fooled astronomers for a while. They're wondering, what are these new stars doing in the middle of it? Well, it turns out that's a couple of other stars that ran into each other, usually white dwarfs. And with a video or astrophoto cameras with exposure time set just right for the globular, you can actually see red giants in there, the end of life of average sized stars. The evidence of the intermediate mass black holes and solar mass black holes in some scopes means it looks like it might be a smaller or older galaxy pulled in. In the case of this one, most of these globular clusters are a long way away. This one is 33,000 light years away because it's out away from the plane of the Milky Way. It's up there circling around. It's pretty big. When you're looking at the last two objects, this one is 84 light years across. This one happens to be 13.7 billion years old by the spectrometry of the stars. And this guy has the mass of about 230,000 stars in that ball. And like I said, it's a retirement home for stars. Jim?
All right. Yeah, and I'll just show you real quick, like Jim mentioned, where it's at, but I'll just show you real quick where it's at, the night sky. It's very close to what Rick was showing in the in Cygnus. So this one is just down kind of in between Lyra and Cygnus, in between Albireo and the constellation of Lyra. So again, it's pretty well straight up. All right, very good. Thanks, Jim. That was good information on globular clusters. We look, when we're doing telescopes visually, globular clusters are really cool things to be able to look at because, especially some of the bigger ones like Omega Centauri or M13, the Hercules cluster. And from a very dark sky, they can almost take on a three-dimensional look, like a ball of stars, and you can almost see some depth to them if you're at a really dark sky and you're looking through a telescope. And that's true for a lot of the objects we look at, like star clusters and things like that, and even galaxies can look a lot better when you're looking at them from a dark sky. So that's why the astronomy community always prefers to have minimal lighting, so that we're able to be able to see some of these fainter deep sky objects. And most of the time, when we're looking and going for the really deep stuff, we'll try to do it when there's no moon in the sky, because the moon is kind of natural light pollution. But sometimes, it's kind of fun to look at a nice crescent moon at the same time. All right, Rick, I'm going to show everybody your telescope and you can talk about it a little bit. Let's see. Okay, here we go.
Yeah, so for anybody who might have dialed into these in the past and seen my telescope, this is a second scope I got in the last year. It was my pandemic project. It's a little scope. It's called the William Optics Red Cat 51. It's a about a 380 millimeter equivalent focal length. So it's a very wide angle field of view. And to really see some of the objects I'm showing you today takes something this wide angle to be able to image them completely. I'm not actually on that mount tonight, but that is a mount that I have. And I'm running a 26 megapixel color camera on the back. It's a cooled camera. You can see it on the back there. It doesn't look like a traditional camera because in order to reduce the noise in the images, it's got a thermoelectric cooler on the back that is cooling the sensor down below ambient temperature to keep that noise down in the images.
Very good. So if you want to go ahead, I'll stop the share and you can go to your next object.
Yeah, I got it ready to go here, and you'll see the wide angle nature of this little scope. Well, let's see, let's get to there. Share. So what we're looking at here, you're actually seeing two nebulas in one. The main one here in the center is appropriately called the North American Nebula. If you look at its shape, you kind of see the Gulf of Mexico here, and the Mexico Peninsula down here, and maybe a little bit of Florida. And I like to joke with everybody, the reason you don't see California over here is because it fell off into the ocean. Over on this side, this other blob here is known as the Pelican Nebula. And if you look at it, you can kind of see his beak here and kind of his wings sweeping back here. It kind of looks like a pelican in flight. Oh, I forgot to mention, this nebula is also located up in Cygnus. There's a lot of good things around Cygnus to see. Now, something to explain about this image, you'll see the stars are looking kind of greenish over here. That is not natural. That is because in order for nebula to really pop out for you, I've got a very narrow band filter on the telescope. And that filter is causing things to look a little greenish. This area down at the bottom of the nebula, where you can see some really dark red, some really dark definition down there, is known as the Cygnus wall. It's something that people like to zoom in on with higher powered telescopes and really image. It's a very pretty area. This nebula, to give you an idea of how large it is, it's about 2,600 light years away, which relative to us isn't that far away compared to some other things. It's in our general galactic neighborhood. And it is about 90 light years across. Now, to also give you an idea how large this object is in our sky, if I had the moon in this same picture, the moon would only be about the size of, or roughly about the size of the Gulf of Mexico down here. So this object is enormous up in our sky. It's just, again, it's so dim that we can't see it with our own eyes. The reason it's very red is, again, partially the filter I have on it, but it is largely a red object given off by it's largely hydrogen gas in this object. But with other proper photographic techniques, you can actually pull out some other colors in it. There's actually some blues and some golds in it too when it's photographed differently. So that is the North American Nebula and the Cygnus Nebula.
And I'll just show you where that's at in the night
I'm sorry,
sky.
Swan Nebula in Cygnus.
Yep, and now we're back towards the tail of Cygnus. That's where the North American. So everything's kind of been straight up. So Cygnus has been very popular. All right, Bernie, I'm going to share your telescope, and then you can probably help answer Sarah's question about what the unistellar is.
Okay. Let's see. I see you. I don't see me, but no problem. The scope I'm using tonight is one of my popular favorite scopes to use in outreach events because it's very quick to set up. It's only takes about 10 minutes and you're up and operating. It's fully motorized. It's fully autonomous. So you just turn it on and it sweeps the sky. It finds out where it is. And then it says, okay, I'm ready. What do you want to look at? And then you bring up the program that you saw a little earlier on my phone here, the Unistellar app, and you just tell it, I want to go to this object, and say go to, and it goes there. So that is the software is basically the control software for the telescope, but it also, once the telescope goes to that object, then it feeds a video of that object back to the app, so you can see it on the phone or iPod screen, depending on what kind of computer or phone you're using. So with that in mind, let me switch over to share, and we'll see if it's going to work for me this time without having to restart it again. Okay, so we're sharing, and I'm going to launch the app, and no, it kicked out on me again. Little problem with that particular function. For some reason, it doesn't like to start and stop. So I'm going to have to start it up again. And this is, by the way, this is the screen where you select what you want to look at. And you punch in, you tap on the object you want to look at, and then the scope goes there. So just beforehand, I had told it to go to my next object. So that's what we're looking at now. And this is called M27. It's also known as NGC 6853. It's also known as the dumbbell nebula. I'm going to zoom in on it a little better. By the way, these are live feeds. What you're seeing is a live feed from the telescope looking up into the sky here in Tucson, Arizona. Now, M27 is another planetary nebula, similar in construction to the previous one that I showed you, the Helix Nebula. However, this one is younger, and because it's younger, it is not as large, doesn't cover as great an area. And for that reason, it's also brighter. So as you probably are noticing, it's much brighter than the previous one. And it is a smaller. So that tells you right away it's younger, and therefore it's going to be brighter. Now, this one is in the constellation Vulpecula. That constellation is just below Cygnus the Swan, if you know where Cygnus is. Cygnus the Swan is almost straight up this time of year. So if you look straight up in the darkness, you will see what looks like a huge cross. And that is Cygnus the Swan. Now, M27, or the Dumbbell Nebula, is located near the star Albireo, which is the bottom star of the cross. I'm telling you where it is because you can find this one with binoculars. If you have a good pair of binoculars and a nice dark sky, and you look up in that general area, you can find this. Now, it's relatively small. Don't expect it to be this large in binoculars, but it can be spotted. Now, you'll notice this one isn't circular in shape like the helix was. And the reason for that is because there's interstellar clouds out there that kind of block the gas from swinging out like it normally would in a circle. So it kind of instead ended up looking like it shot a jet in one direction and in the other direction. Again, it has the telltale signs of hydrogen gas on the outer shell. If you look along the outer curvature there, you're going to see a red glow. And that again is ionized hydrogen from the that was blown off in the original shell that came off the star. And that star is now illuminating that gas and causing it to ionize, and hydrogen ionizes red. Now, if you look closely, right dead center, there's a faint star right in the middle. That is the originating star of the planetary nebula. And that star, like the Helix Nebula star, will eventually turn into a white dwarf star. This particular white dwarf is going to be really, really large. It's going to end up being about half the size of our sun once it reaches the white dwarf state, which is, for white dwarfs, a really large white dwarf. This nebula is about 1,360 light years distant, so it's about twice as far away as the Helix Nebula. And it's about 1.4 light years wide. Now, you might remember the Helix Nebula was about 3 light years wide, so about half the width in size. And that's primarily why it's brighter. It was discovered by Charles Messier in 1764, about 50 years earlier than the Helix Nebula, primarily because it's brighter and Messier, with his little 3-inch scope, was able to spot it. This is visible in binoculars, as I mentioned before, and if you get a chance, try spotting that. It's very close to the star Albireo, and that is M27, the Dumbbell Nebula.
All right, and that one is actually visible when you do visual astronomy as well. So I'll just show you again where it's at. So like Bernie mentioned, Vulpecula is just by the head of Cygnus the Swan. So again, we're looking straight up. And this is the constellation of Vulpecula. And in a visual telescope, you won't see the colors like you can see in Bernie's telescope, but in a visual telescope, you'll actually be able to see shades of gray. And if you use your averted vision and to see some of the really dim stuff, you'll be able to make out the hourglass or the dumbbell shape.
That was actually the very first object I saw through my very first telescope.
Oh yeah,
It's very visible.
It's a great one to look at. I show this a lot at star parties because it looks like what it is. You know, it looks like a dumbbell. All right, thanks, Bernie. Jim, let me show everybody your telescope, and you can talk about it here in a minute. Let's see. All right, over to you.
Hey, there's my 10-inch light grabber that I'm sitting right by that table that you can see there. I've got my laptop on the table now, though, so I can do the processing of everything that's going on. You'll notice the biggest thing that sometimes jumps out at you is on the top of that telescope is a little telescope, a little camera. That camera that Jim's circling it helps me line up align the scope. Actually, I align the mount. I align the motors and everything to help find. That's called a star sense. Stellar alignment or star sense star align telescope. When we came out here this evening, as dusk was going on, the sun had set and it was getting dark. I went over there, turned the telescope mount on, and hit my controller handle. I said, align. 3.5 minutes later, it had looked at 4 spots in the sky, 100 stars in each spot, aligned them to what it knew in its brain were right. And in 4 minutes, I had my first object in the camera. On the back of the telescope is a video camera. It's called Malindam Exterminator. And what it does is it's a CCD camera that's intended for live viewing. So the pictures I show are anywhere from 10 to 20 seconds of signal acquisition, and it goes to my monitor. And after that, it updates it at 30 cycles a second with a new picture. So you can't see the flicker. But that camera is pretty sensitive, but it's old tech. And the way you can tell that is look at all that cables, wires, and other ways to get trapped behind it and to wrap up in the scope. Bernie's camera, on the other hand, has one line going out there. He's got a USB line that does everything. And there, I've got is 2 video lines, a power line, and a way I can control that camera from my computer here, where I'm about 8 feet away from it. But the reason I like it is it does fantastic work with the sky. So that's my little bitty setup, and I had it out in the backyard. You might notice on the monitor that's in front of it, that's what I take to star parties. And I use that to sort of cross-check myself in what I'm looking at. And my laptop, not sure if it's telling me the right thing, because that has to take the signal coming out of the camera, which is an analog signal, and convert it to digital so it can go out on the internet. But out in front of there, I don't know if you can see on there, but that's all the camera control information on there when I started it up today when the sun was still up, so I could see what I was doing. So that's a 10-inch Schmidt-Cassegrain telescope, and the finder that's on the right of that Star Sense camera, I never use. I haven't used it for the last 3 days out because that Star Sense camera just gets me perfectly aligned. I don't have to look through that finder. Jim?
All right, thanks, Jim. So now you can go ahead and share out your object.
Okay, let me go get an object here of some kind. Seems to be, so give it to me. Yeah, this seems to be the night for planetary nebula. What you see there is an object still up in that same region of the sky, up around the Summer Triangle area. This is, again, in the constellation Lyra. This is a planetary nebula called the Ring Nebula. And to review a little bit, a planetary nebula is how a star up to 8 times the mass of the sun ends its life. So it doesn't really explode. It's more like a gentle sneeze. What happens is when 75% of its hydrogen is used up, it's all consuming it from the inside up. It's using the hydrogen to make helium. And we live around it for 10 or 12 billion years while it's doing that. That's where we get our light and our heat from. But those nuclear reactions, in the case of our sun, probably about 6 billion or so a second, these nuclear reactions, fusion reactions, where the helium is making hydrogen, start at the center, where the pressure is highest and the temperature is highest. And so it combines these at a regular rate as it moves outward. Well, after it's used up about 75% of that, the center part of the star is dead. It's like campfire ashes. And gravity, though, is still pulling everything in. So the sun starts to shrink. The star starts to shrink. And that extra heat and pressure causes that helium it's been making for about 10 billion years to turn into first carbon and then oxygen. And it starts going away because there's still plenty of protons left from when the sun was a star. And so it makes interesting elements that way. Sometimes it might throw in a little nitrogen and neon. But what you see there is that guy went and took a trip that he didn't want to make and started spreading the gas out. And the reason it glows is, I think Bernie explained pretty well too, is that it's when those gases are running away, in this case, hydrogen and oxygen are running away, plus the helium. We can't see the helium is neutral. Hydrogen and the oxygen are running away. That white dwarf has now been compressed. Now that carbon turning into a stellar diamond. That diamond in this star, you might be able to see it a little bit in the center of that object you're looking at. Diamond is about the size of the Earth. You could really corner the market if you get your space cruiser out there and hook the tow rope around the thing and bring it home. But you'd have to have a long rope because that thing's about 500,000 degrees. And that's what ends up making that thing glow. The ultraviolet energy from that makes it like a neon sign. So the hydrogen is the outer gas, and the oxygen that was made on the inside makes a bluish gas. And if you have a camera with the pixels too big, like I do, the hydrogen and the blue, the hydrogen red and the oxygen blue will overlap and sort of make a yellowish overreaction, merge reaction by some of the pixels. But there is a bit of yellow in there too, because there's a little bit, it turns out that when that star was formed, a little bit of sulfur got picked up from a prior supernova in the area. And so it does have a little bit of yellowish brown in it, but not as much as I'm showing. The center is blue-green from the oxygen. The outer part is the red from the hydrogen. This object, the Ring Nebula, and the Messier Object 57, is about 7,000 years old. So it's quite a bit older than some of the other ones we've been looking at. It's 2,600 light years away. So if we think about the first one we saw was 600 to 700 light years away, then we saw one that was twice as far away in the helix at 1,300. This is twice as far away as the helix. So this thing is or 4 times as far away as the helix, and twice as far away as the dumbbell. And this one is 2.5 light years in diameter. It's still running out, but it's running out, running by that I mean moving out. Its expansion velocity for this one is 17,000 meters per second, or 17 kilometers a second. To compare it with a younger one, like the dumbbell was, the dumbbell's moving out at about 35 kilometers a second. This one is 17 kilometers a second. That's a lot of distance in a fast time, but you know what? In the 250 years or so since this was discovered by Charles Messier in the mid 1700s, we haven't noticed the size changes. So far away, we haven't detected a spatial change in it yet, but we can tell by the Doppler effect on the gases that are coming at us. The reason for the ring shape, all planetary nebulas we'll look at have a different shape. The reason for that is the magnetic field of the parent stars. It manipulates the gases that are coming out because they're charged gases because of the heat of that center star. It manipulates them to follow the magnetic field lines. And so when I look at that and see a donut or a Cheerio or bagel sitting out there, what I can is the fact that I'm really looking at a bit of a ball. And really, the sides that are facing exactly at us are pretty thin. And we don't see as much density as we see looking at the outer shape. And so that is almost like the dumbbell, but looked at head on. So planetary nebulas will look beautiful. They're some of the most beautiful objects in the sky. And with a big enough telescope, you can actually do some pretty good observing with it. Jim?
Yeah, and this is another really good one that is cool to look at even visually in the night sky. You'll be able to clearly see the material. It'll be in shades of gray instead of color. And it does, I refer to it as a Cheerio or donut or a ring, because that's what it looks like in the telescope. And it's as far away as it is, as big as it is, it's pretty cool to look at. And this one, again, is pretty much straight up in the constellation of Lyra. So it's up in the vicinity of Cygnus as well. If you look straight up this time of year, one of the things you can see is what we call the summer triangle. The summer triangle is the brightest star in that triangle is Vega, which is this one right here. And then you go up to Deneb, which is in the tail of Cygnus. And then you come all the way over here to Altair, which is in Aquila the Eagle. And so this forms the summer triangle. And so it's straight up right now, but it'll start fading as we start moving into winter. And it'll get this whole triangle and these constellations will get lower in the night sky. All right. Rick, you ready?
Yes. So what I've got for you this time, it's known as the Elephant Trunk Nebula. The reason for that, it's a little hard to see in this exposure, but there's this dark plane of dust right here that kind of protrudes out like an elephant's trunk. I know it's a reach, but that's what they've called it. This object is actually larger than the other ones I've shown you, although it still fills the frame. It's further away. It's about 3,000 light years away. So the thing you're looking at here is hundreds of light years across. It is absolutely an enormous structure. Couple of things of note, the bright star there in the center is actually a triple star. It's got a very bright white primary star and two smaller blue star companions. Can't see it in this picture. Would take a more powerful telescope to be able to split those apart. But all you're seeing these dark areas here. Those are called dust lanes, and what's causing those? There's actually matter in there. It's carbon dioxide frozen with a piece of dust, and that creates a compound there that is very light absorbing, and so that's what creates these dark dust lanes you see is all that that frozen dust. So this is located up in the constellation Cepheus. And the nice thing about the Elephant Trunk Nebula is we can almost look at it all year long because it never rises and it never sets. It orbits so close to the North Star that it never actually dips below the horizon.
All right. Yeah, that's another tough one to be able to see visually, but it shows up wonderfully in cameras.
Yeah, it's a fun one too to explore with more powerful telescopes. You can zoom in on different sections of it and pick out different detail in it.
So as Rick mentioned, this is up in Cepheus, so it's right kind of behind and to the right of Cygnus right now, and not too far from the North Star, which is right below it. So here's Cepheus and Ursa Minor, and this is the North Star right here. So that's why, since everything rotates around the North Star, Cepheus is not very far, so it just stays pretty much up most of the time. You have to get further away from the North Star for things to be able to set. Okay, Bernie, you ready?
I am. Let me switch over here. Okay. I have another planetary nebula for you. As Jim mentioned, this is planetary nebula night. So we're getting a good cross view of different planetary nebulas this evening. So let me see if I can bring that up for you. Oh, worked the first time that time. Got lucky. Okay, this one is called the Blue Snowball Nebula. It's a planetary nebula like the previous ones, M57 that Jim showed you, M27 that I showed you. However, the Blue Snowball, also known as NGC 7662, is much further away. It's about 4,000 light years distant. So it's still in our Milky Way, but it's beyond what the human eye can see. It's quite a bit further than what the human eye can see. A good rule of thumb is that most or almost all of the stars that you see on a dark night in the sky are less than 1,000 light years away. This particular nebula is 4,000 light years away, so quite a bit more distant. And for that reason, it's rated at magnitude 8.6, which is well beyond the ability of the human eye. Now, because it's much further away, it's a lot smaller visually to look at. And you have to magnify the image. But I'm sure you can spot it, the blue snowball. It's pretty obvious, isn't it? Over on the right center. So let me zoom in on it a little bit. And then you'll notice that it has a very, very blue color to it. Very, very apparent blue color. This planetary nebula is in the constellation Andromeda. Right now, Andromeda is almost straight up, slightly north of straight up. It's in the same constellation as the Great Andromeda Galaxy. Not too far away from it, actually. It was discovered by William Herschel back in 1784. it's about 1.5 light years wide, which is about the same width as M27, the one I previously showed you. So you can tell it's much further away to be so small in comparison. Now there is a central star, but that central star is not visible in this image. You need much higher magnification and a much narrower field of view telescope to be able to spot the central star. That central star is magnitude 13, which is, the human eye can see on a good night with very good vision down to about magnitude 6 or 7. So that central star is magnitude 13, way beyond what you could see with the human eye. That central star is an O-type star. Now, an O-type star is a very bright, very large, hot, extremely hot star that is giving off light that is white, but more towards the bluish white. And that's the reason why the nebula has a blue cast to it, because it's reflecting a lot of the light that is coming from that bluish O-type star. And this is the blue snowball nebula.
All right, yeah, definitely is blue. And yeah, that, like Bernie was saying, that's fairly far away. So let me just show you real quick where it is in the night sky. Again, pretty close to Andromeda and not far from the Andromeda galaxy, which is right in this area, right in here. So it's very close to that, off the tail of Cygnus and just a little bit above Cassiopeia. All right, over to you, Jim.
Okie doke. Let's see what I can conjure up here. And there's kind of an unassuming little cluster of stars. This is called Caroline's Rose. It's in the New General Catalog, which is one of the primary catalogs we use. New General Catalog, the Index Catalog, and the Messier Catalog are the main catalogs we use. In fact, although most of the Messier Catalog also has NGC numbers. And if we take a look at this thing, before I talk about Caroline's Rose, it has a bearing on the New General Catalog. It turns out the New General Catalog was put together by an astronomer named Dreyer, who actually, when we were just hearing about Wilhelm Herschel, or Frederick, he changed his name from Friedrich Wilhelm Herschel in his native Austria so that when he moved to England, where he ended up doing most of his astronomical work for the royal family, he was an Anglophile, and he called himself Frederick William Herschel. So he really kind of thought he should have been born in England. Well, his sister, he brought over from Austria to help him, not helping with astronomy, but he was an orchestra conductor and a composer. He heard that you can do better music if you polish a mirror like Sir Isaac Newton had done to make a Newtonian reflector, a parabolic mirror. So he would make these mirrors to bounce light off of them and see if you could see rings in it. And those rings would be like chords of music. And he was trying to invent new musical sounds. But he would test these mirrors out in his backyard. So what did William find? He found the planet Uranus with his sixth mirror. And so he found this thing, but he also found lots of other things. He ended up spending most of his time in his later years as an astronomer. His sister Caroline was helping with the orchestra. She was supposedly had one of the most beautiful voices in Europe, but her parents didn't want her out of the house because she had been badly scarred by smallpox. But he knew that she was a brilliant person in other ways. So he brought her over, and she was helping him not only with his orchestra, but with his mathematics on his scientific work. And so she started observing on her own. And she ended up discovering 11 of her own comets. And she made up a catalog of 1,600 planetary nebulas and also a lot of open clusters. That ended up with Herschel's work and Frederick Herschel's son, John. That ended up being compiled almost 100 years later into the new general catalog. So Caroline actually found Caroline's rose, and it didn't get an NGC number for about 100 years, and it's her own data. So what you see here, she thought it looked kind of like orange petals when they were laying there, or when she was seeing it in the scope. And so that's what she called it. But at the time, they only thought there was maybe 1,500 stars there. So what I'm going to do with this guy is I'm going to change the imaging. Right now, that's 2 seconds with the camera. I'm going to up that a few seconds, and you can see what really people found out later was in that cluster. And it picked up a different name at that time. Let's see what we do here. I increased it up to about 7 seconds, so I'm going to count down a little bit to myself and see what we get. It's getting there, I hope. There. That is that cluster. And there's so much light coming into the camera, I'm getting a lot of back sky glow. So I'm going to make some adjustments to that. And you can see behind the curtain right now, I'm going to remove some of that because I have to change. I'm using a histogram to adjust the background. Okay, now I'll get back to regular vision. Now there is a picture of what that cluster looks like. And now you might be able to detect what its second name is, the screaming skull. Right in the middle, some people think they can see the shape of a skull in the middle, and sometimes eyes up near the top right of the image, and down near the bottom, a chin. So that Caroline's rose, the pretty little cluster she thought she found, became a monster. And some of the facts about that thing. Open clusters, like this is, don't usually hold their shape forever due to natural rotation, and after it forms, and it causes the stars to disperse. This object, commonly called Caroline's rose, but it's also called the screaming skull, and Herschel's spiral cluster. It was discovered in 1783 by Caroline, 2 years after her brother Frederick had discovered Uranus, the planet. It's located in Cassiopeia. It's magnitude 6.7, so you can just about pick it up with binoculars, but it's small, maybe almost too small to find the binoculars, because it's 7,500 light years away. 7,500 light years is a long way away, as Bernie was saying about what you normally can see with your eyes. But it's also 35,000 light years in diameter. That's a lot of stars. At low exposures, it looks like it's got about 150 stars, but with a little augmentation, there are over 15. There have been estimates from 15 to 150,000 stars in this open cluster. They hold each other together by gravity. They're gravitationally bound. They haven't spread out. They've even got some relatively recent giant stars in the middle. Group gravity is keeping those stars from dispersing, and it's leading to its calculated age of 1.75 billion years old. Yeah?
Yeah, so that's fairly old for an open cluster, isn't it?
Yeah, it is. There's only about 2 that are older.
Yeah.
I had one on my alternate list that was actually close to 6 billion years old, but this one's pretty impressive on its own.
Right. Most open clusters are fairly young because they're born out of the nebulas, like the Orion Nebula and some of the other nebulas that we occasionally look at. And so once they use up all that hydrogen gas cloud and make stars, then they travel around the Milky Way galaxy as this little family of stars. And, as they migrate around the galaxy, it's kind of a loose collection of stars. So shortly after, eventually the outer layers of the cluster will start drifting away, and then the next layer, pretty soon the open cluster is no more, and the stars are usually all by themselves. And so open clusters usually don't last too long. Just depends on where they were formed within the Milky Way galaxy and how as to how long they might stay together.
Oh, Jim, I have to apologize. I went to my fourth object before the third instead of the third, so I'll go to the third one last.
Okay, yeah, that's fine. I think what we'll do is we'll probably do one more object each, and that'll give us about an hour and a half. But anybody that's on YouTube, if you guys have an object that you want us to look at or something, maybe for, after we go through this next round, we'll see if we can tap into anything. So if you have a request or again any questions, type them into the chat and we'll get right to them. All right, let's go on over to Rick.
Well, you guys just had a great straight man conversation into my next object, because I have exactly what you were talking about. I have a young cluster coming out of a nebula. So
I love this one.
yeah, so this nebula is called the Heart Nebula. You can see why. You can see the shape there. There's the peak of the heart there and the two lobes coming out. Now its companion over here has a rather whimsical name. If this is heart, then that is soul. For no other reason than they thought it was funny. But coming back over here to the Heart Nebula, what you're seeing is this is a fairly bright nebula. It's about magnitude 6.5, which is brighter than some of the other things we've been looking at. That brightness is driven by this star cluster in the center. And it's exactly what Jim was just talking about. This is a young star cluster. It's only about 1.5 million years old, which is relatively new. And some of the stars in there are massive. They're 50 times the size of our own sun. So some very, very big stars in there that are driving all of this, all the heat that's lighting all this up. You'll also notice off to the right here, there's another star cluster lurking over there. And the Sol Nebula within itself also has little star clusters within it. So these nebulas are the factories that have been creating these stars. As that gas collapses, stars are created, and eventually, enough stars are created that it chews up all that gas, and that nebulosity goes away. But not in our lifetimes. And this is also, again, a large object. This is very far away. The last one I showed you was 3,000 light years away. This is 7,500 light years away. So we, still filling the screen, but further away. So it's a pretty big object.
Yeah, and this is another one that's best in camera. It's a little bit hard to see a lot of detail visually because it is pretty faint.
You can see the star cluster in it, but seeing some of the nebulosity can be tough.
Right. Yeah, and just kind of circle the star cluster portion of it. It's kind of, right in the center. And if you go to the right, it looks like there's another little cluster right there. So,
yeah, there's a little cluster right there too.
So this nebula would have been larger, before all these stars were born, and they've just started using up the gas, and pretty soon the heart will no longer be, and the soul will no longer be, and there'll be an open cluster, and we'll probably be able to look at, we look at something called the double cluster in Perseus, and that is two concentrations of clusters of stars, and that is pretty cool to look at visually because it just fills up the eyepiece with stars. But before those stars were born, there was nebula there. That's what they were born out of. So the gas cloud, and nebula just means gas cloud or cloud, is what, it takes a cold hydrogen nebula, gas cloud, to be able to form the stars, and some sort of agitation to get them going. Otherwise, the nebula and the gas cloud just kind of sits out there.
And these these nebulas sit in the constellation Cassiopeia, which is located pretty close to the North Star. So again, this is a nebula that does not rise and does not set. It's always in our sky.
Yeah, and I'll just show you real quick where it's at in Stellarium. So again, it's right up here by Cassiopeia, and so it's Cepheus. You know, we talked about Cepheus before.
Comment.
Okay. All right. So we have before we go on, let's just so we've got a comment. Saw this event on the JPL website. This is from Benjamin when looking at the page for my local group in the Treasure Coast in Florida, enjoying it. Well, thanks, Benjamin. Appreciate it. And Christina asks, why are some nebulas brighter than others? Well, that's a good question. And some of it's going to depend a little bit on the concentration of the nebula, how far away it is, how many stars that some of them are called emission nebula. So what's happening is we're able to see the gas cloud because the stars that were born within the gas cloud are illuminating that cloud. So those are emission nebulas, or reflection nebulas, actually. Emission nebulas are more nebulas that are formed because of the stars are emitting the gas and the different wavelengths that allow us to see it. And Rick or Bernie or Jim, if you guys want to kind of maybe try to explain that a little bit better, that would be fine.
Well, sometimes how you see it depends on the instrument you're seeing it with. And so what can make them brighter is the pixel density of the camera, because a lot of times we can, with bigger scopes, look at these nebulas, but a lot of times if we want to look at them, we have to do it with a camera to intensify the image. One of the reasons is your eye takes about 6 pictures a second and throws it away. So you got about 1/6 of a second to get that image in. Yet we can do many seconds. Most of the things I've been doing here have been around 10 to 15 seconds. So if I say that's 60 times as much time we've got to look at that. But the other thing is the size of the instrument. So my 10-inch scope, if I take 60 times 10, it's 600. That's a lot more light coming in than your eye can tell. So even so, if you can see it with your eye and it's concentrating the energy that's coming out of that to a point, it looks bright. It looks, that's why when you focus something, it looks a lot brighter. If you're using a camera, depends on your pixel size. Rick and Bernie have a lot tighter pixels than I do, and they can actually get real pristine colors. I get some of them that kind of wash over each other. So it's basically how you're seeing it, as well as how far away it is and how much energy is actually lighting it up.
Right, because the other thing that impacts it is the frequency of the light we're looking at. Some of these things are beyond our visible spectrum. So it takes, although the camera might be able to see it, when we throw a filter on, we can filter out all the signal we don't want to see and just see the signal we want to see, and that will make it appear brighter. It also, dark skies help. What takes 300 seconds exposure here in a darker sky may only take 60 seconds.
Yeah, exactly. So, and that's another reason why, you know, the dark skies are critical for being able to do the observing on some of the fainter deep sky objects that are just too hard to be able to see if you've got, you know, a bright moon or a lot of other light pollution going on. So, all right, Bernie, you ready for your next one?
I am. Let's see if you can, you see me in the glow? Yep, there I am. All right. So my next object is going to be out of this world in comparison to the objects that we've been looking at so far. All of the objects, if I'm looking back at what we've looked at so far, are within our Milky Way galaxy. So now I'm going to take a big leap and go out beyond our galaxy, and we're going to look at another galaxy instead. So what we have on the screen right now is what is called the triangulum galaxy.
We're not
It's
seeing
also-
your picture yet, Bernie.
You're not getting it?
No.
Oh, okay. All right, let me back up. Where is it going wrong? Let me try that again. Bear with me.
There we now
Okay.
starting to get the script share.
All right, didn't take the first time. Okay, there we go. Now I should see it. Right? You're seeing it?
Yep, we got it.
Okay. This is called the Triangulum Galaxy. It's also known as M33, and it's also known as NGC 598. The Triangulum Galaxy is a true spiral galaxy. So if you look closely there from the center, and I'm going to put the center as close to the middle as I can. All right, there's the center. So if you look out from the center, you'll see there's numerous arms swinging out from the center, spiraling out from the center. There's a really nice one that sweeps out to the right, and you can follow it almost to the top of the screen. Another one that comes out about the top and swings around to the left side. Another one that comes out near the top, swings around the bottom. So if you and another one that comes out more around the bottom of the center and swings out to the bottom right. So there's numerous spiraling arms to this galaxy. Now, what is a galaxy? A galaxy is billions and billions of stars that have formed in a vast, humongous spiral. And in the case of the Triangulum galaxy, we're looking at approximately 40 billion stars. The Triangulum galaxy is 2.7 million light years distant. So it's just a little bit further than our closest neighbor, the Andromeda galaxy. Now, you'll also notice there's a bunch of points of light in the same frame. Those are stars, but those are stars that are in our galaxy. When we look at another galaxy that is far, far away, we have to look through our galaxy first. So those points of light that you're seeing in the image are all stars within our galaxy. So if you can mentally remove all of those points of light, those little dots, which are stars in our galaxy, mentally remove those, and you're left with that big spiraling mass. That spiraling mass is 2.7 million light years away. In comparison, the points of light that you see, the stars that you see, and those are foreground stars. Those are maybe 10, possibly 20,000 light years away. So you're talking thousands of light years versus millions of light years. So that galaxy is much, much, much further away. And that's why it looks more like a cloud than it does stars, because it's so far away that we can't see the individual stars. They all blend together in more like a cloud or a fuzz. It's about 61,000 light years wide. So it's slightly smaller than the Milky Way galaxy, which is estimated at about 100,000 light years. So slightly smaller than our galaxy. It was discovered in 1654. Now, back then, they had no idea what it was. They called them nebulas. Basically, the word nebula comes from nebulous. It's something fuzzy, but they didn't know what it was. In fact, galaxies kept being known as nebulas until the middle of the 20th century. It wasn't until the early 1900s that it was finally determined that galaxies were actually groups of stars that were at vast distances away. This one can actually be seen by the naked eye under extremely dark skies if you have very good vision. And right now it's almost straight up. So if you knew where to look, it would be kind of a good contest to see if you could spot it. I've seen it once with my just with my eyes, and out at our deep sky site that is pitch black, and my eyes were well dark adjusted, and I was able to just barely make it out. The Triangulum galaxy is the third largest member of what we call the local group of galaxies. The local group is a number of galaxies, including the Milky Way galaxy, the Andromeda galaxy, Triangulum galaxy, the large and small Magellanic clouds, and a few other galaxies that are gravitationally bound to each other. And for that reason, we travel through the universe as a group. It's kind of hard to imagine that something so huge and so far away could be actually gravitationally bound to us and us to them. But we are, and we go through the universe as a grouping because of that. You'll notice the arms are kind of clumpy. They aren't uniform. And that clumpiness is because there are star-forming regions within the some of the arms. If I zoom in, you'll notice there's clumpiness there, right? Dead center, for example. You'll notice clumps of what look like brighter areas. Those are star-forming regions, areas within the arms that are forming new stars as we watch. And there's one particular area in this arm, the arm that's coming down, got it kind of centered right now. If I scan down here, you'll notice there's a fuzzy spot right there in the middle. That is actually a star-forming region in that arm of the galaxy, just above that star. That star-forming region is forming so many stars that it has a very bright intrinsic brightness. And for that reason, it's been given a name of NGC 604. And it's been studied by astronomers for many, many years because of that bright star-forming area within the galaxy. So that is the Triangulum galaxy, 2.7 million light years away.
Yeah, that's a really cool galaxy to look at. And you can see, as you were mentioning, Bernie, you see all kinds of little activity going on within that galaxy, and thinking it's, 2.7 million light years away. It's just amazing that we can see that much detail with it. And I'll just show you real quick where it is in the night sky in case you want to go out and try to see it. As Bernie mentioned, it's pretty close, pretty much straight up. A way to find some of these, a lot of times you can find what we call the Great Square of Pegasus. So again, that one it's up probably a little bit. Let's see, it's probably a little bit to the south of straight up, but you'll see the square, and if you come off of the one corner, you'll see kind of like looks like a V coming off, and that's the constellation of Andromeda. So if you come out the two bright stars and then go up the two dimmer stars, the constellation or the galaxy is right in here. Another way to find it is off of Cassiopeia, which is the W you see in the night sky. If you look at the steep triangle here, not the shallow one, but the steep triangle, it kind of points towards, it's a little bit low, but it kind of points towards Andromeda. And then if you were to go about the same distance further than the Andromeda, and that's where you're going to find the triangulum is out here. And this is the constellation of Triangulum. And the galaxy is right up there. So it might be a good test to see how your skies are, and go out and see if you can see it with, binoculars or pair of binoculars. Is a real easy way to do a lot of sky gazing. If you can get back on like a 0G chair or something like that, recline back, support your binoculars, and you can scan around. You can look at, you can see the moons of Jupiter. You can see, Saturn. You can see all kinds of cool things, and you probably should be able to see a little fuzzy spot for Andromeda, and you might even be able to see the Triangulum galaxy. All right. Well, unless you guys have any other objects you really want to share, I was going to call it quits there.
Okay, I got the owl, but I didn't know if you wanted to go to that last object.
Yeah, let's go ahead
Or
and
not.
we'll.
I got one more quick one, Jim. Just as a
All right.
follow on.
I can bring up
Okay.
another one too.
All right. Well, we can
So-
do one more round.
Well,
I'm game.
I showed everybody before the North American Nebula, and I told them that California fell off into the ocean. Well, I found it. This nebula is known as the California Nebula. Again, a very, very large structure up there of gas. You can see it going from the bottom corner here all the way up to the right.
Yeah, so it's kind of elongated and in the shape of California, I guess. So that's why it's called the California Nebula. And yeah, it
Our so-called
disappeared
cloudy
off of-
skies have gone away, Jim. It's clear out here.
Yeah, it's
all right.
improved. Okay, that was my
Very
quick
good.
one.
All right. Well, Bernie, why don't you go ahead, and if you're ready for another one, or Jim, you can do the owl.
When
Well, I
we have
got one
Jim,
up
I'm still
right now.
slewing.
Okay, then Jim, why don't you go ahead and show him the owl?
Okay. Well, what we have here actually is more like a bat. It's kind of up, almost upside down right now at this season. I want to make sure that, let me hit the, yeah, I guess that upper right, very upper right, there's two very bright stars. That's his feet. Down the lower left, there's one that might even be glowing. It's so bright, so intense. That's one of his eyes. And right to the lower right is another eye. And in between, that's his spine going down towards his feet, and his wings are sort of like E.T. He's waving at us. One is kind of horizontal right now, going off towards the edge of the screen, and the other one's down at about a 45-degree towards the bottom of the screen. This is an interesting little object. It's got some of the most names of most of objects I've ever heard. First of all, its catalog identification is New General Catalog, or NGC 0457. I remember that because that's my mailbox number. The basic name that it originally came out with was the owl, but later it picked up the name of Kachinadal, like a Hopi Kachinadal, or the ET for a long time, it was called the ET cluster. Like it was ET waving to call home. And I had a star party once on Davis Mountain Air Force Base here, where some of the scouts, we were doing a scout camporee, and one of the scouts thought it looked like an F-15. So it does get a few names in it. But might as well talk about what you're actually seeing pretty quickly here. And the owl, it's like we said, clusters are usually a moderate number of stars, all young stars generally bound together because they were formed out of the same cloud, but usually dispersing over time. Usually they do disperse and separate over a few million years, depending on the size and the density. This one is about 8,000 light years away from us, but it's 30 light years across. That's a long distance for only a few stars to be scattered. So I guess we're going to be lucky to see this one. This one happens to be 22 million years old, which is still fairly young for open clusters. It can take up to 100 million years for a star to kick off. If you kick off in about a couple of thousand to a million years, then you're usually a giant star. So 22 million years, and we've got them sitting up there. Those are all fairly big stars, but they're so far away, 8,000 light years, they still look kind of large at us. There's anywhere from, depending on which reference you look at, there's from 60 to 150 stars in this cluster. And the interesting little thing is down to the lower left, where you see the two bright eyes of the sun, the little secret is they're not part of the cluster. They're what's called field stars. They're in the way. They're only about 4,000 light years away. But we couldn't call it the owl without them. So when we describe the cluster stars, we kind of include those stars and call them the owl's eyes, but really they're not part of the cluster.
Yeah, and this is another one that I really love to show at star parties, especially with the kids, because it actually looks like an owl or a flying critter. So it shows up really cool.
Oh yeah, it's also called the dragonfly.
All right. Thanks, Jim. All right, Bernie, you ready?
Well, kind of.
Okay.
What's going on? I'm in the process of slewing to the next object. So let me tell you what.
Well, I'll chat a little bit about our next star party and some of that kind of stuff while you're getting.
I can
going.
share my screen. Maybe it'll show me slewing if nothing else.
Okay. Well, and while you're moving over there, so we do appreciate all you guys coming. We love doing these star parties. We started doing them during COVID, and we thought, this is a great way to just share our love of the hobby while we're, even though we're starting to do in-person star parties here in the Tucson area. So we are planning to keep doing these things quarterly. So I think, as I mentioned, if you caught the very beginning, our next one is going to be February 10th, I think is what I said. And it'll run from 7 to 9 p.m. as well. And we'll stream out to our YouTube channel. I usually put something, a notice out a couple of times on our Facebook page as well, just to remind everybody. But we haven't gotten techie enough to be able to get a good placeholder out there that you can come to and we can stream to, because we are using Zoom to stream it out, and so it's a little bit harder for us to do some of that kind of stuff. But we do enjoy doing this, and I'm glad everybody was able to participate. And when you guys come back, if you want to join us again, just if you want to follow the YouTube page, the channel, then you can probably we'll get notified when we're streaming, and I usually try to do some posts there, or you can follow us on Facebook. Just search Tucson Amateur Astronomy Association on either one. All right, Bernie, last one.
Okay, what I've got here is something I pulled up real quick. This is what's called M71. So if you look at it full field, you'll notice there's a kind of a grouping of stars right in the center. That is called a globular cluster. There's two basic types of clusters. There's open clusters, which we've been looking at previously, and then there's globular clusters. And I think they came up with that name because they look like a glob of stars, and that's exactly what globular clusters look like. They're a big mass of stars that are all gravitationally bound to each other. There's about 150 of these globular clusters that mostly revolve around the center of our galaxy. Some of them below, some of them above the plane of our galaxy. They're very old. Most of them are in the billions of years, and they're made up primarily of very, very old stars. M71 is another example of that. I don't remember the exact distance of M71, but most of these are in the 30 to 70,000 light years distant from Earth. And the vast majority of them have at least 100,000 stars all in one clump. Some of them are even larger, into the 2, 3, and even 400,000 stars, all gravitationally bound in a tight grouping. If you can imagine living on a planet that revolves around one of the stars in one of these globular clusters, you could probably think about there'd be never darkness. There'd be so many stars or suns in the sky that it would be eternal daylight. In fact, it would probably be so hot that you couldn't live, but you'd never see darkness. And that is M71, the globular cluster.
Yeah, I think Bernie mentioned earlier, and he was talking about the closest star system to us, the Alpha Centauri system, is just over 4 light years away. The average distance between stars in some of these globular clusters is like 0.1 light years. So like you said, they're just, if you were on a planet around one of these stars, you would have stars everywhere.
Bright stars, probably
Yeah.
more like mini suns.
Right. Yeah. All right. Very cool. Well, I'll just go around the horn real quick for all you guys if you want to say a last few comments. But I do want to reiterate to everybody that our next one will be in February 10th. It's 7 to 9 p.m. So we're in Arizona, so that's Mountain Standard Time. So Arizona does not convert to daylight savings time. So we actually pick up and move into the California Pacific time zone during daylight savings when everybody else shifts. So we're basically UTC -7 or Greenwich Mean Time -7. So that's another way to find it. And if you go to our website, which is just TucsonAstronomy.org, if you go to the website, there's a calendar on there. Now, granted, most of the star parties listed on that calendar will be in the Tucson area, but we will have our virtual star party will be on there as well. So that'll give you an idea of what you got. Yeah, so Benjamin was saying you might consider scheduling the next live stream, as then it will show up to subscribers feed as upcoming. Yeah, that's what we got to try to figure out how to do. I would try to do that this time around and it wasn't too successful. So we'll work on that. And I think that's a good idea to show it as upcoming to all the subscribers. So yeah, definitely if you want to follow us on Facebook or subscribe to the YouTube channel, then we'll try to, we want to keep doing these things because It is really cool. And you know, if you guys have any objects you want to look at, by all means, let us know. All right, so let's start with Rick. We'll just go in the order we started the telescope. So Rick, if you want to say a few words.
Yeah, I'll just mention in regards to the February virtual star party, we'll naturally, of course, be looking at completely different objects of what you saw tonight. We'll be into the winter constellations. The star of the winter, the Orion constellation will be up front and center. So we'll be able to explore some of the things around it and show you some totally different things. So hope everyone joins us in February.
All right, Bernie.
Yeah, it was a great night. At first concerned that we were going to have clouds tonight, but for some lucky reason, they all blew away and we got clear sky. So hope you enjoyed the evening. We certainly did, and we look forward to February.
All right, thanks, Jim. Jim, you're muted. There you go.
Yeah, pesky mute button. It was kind of surprising tonight. It turned out as well. And when it gets this cold or chill as it is now, there's a good point of it and a bad point. The air tends to get a little crisper, a little clearer. And it actually was a lot better tonight than it was 2 nights ago. The downside is, since I have my scope set up outside and had it set up for the last about 4 or 5 days out here to work on some things, it gets the daytime heat. And so when the sun goes down, I'm chasing focus like crazy. The stars become blobs and have to run around behind the camera and make it come into focus. But it's always fun to do these. And it was, we don't plan our agendas out in advance. And it was kind of interesting how opens and nebulas kind of really were stars tonight. Pun intended.
Yeah, exactly. All right. Well, again, if you guys are in the Tucson area, come join us at some of our public events. Otherwise, definitely join us on our virtual stream. And like Rick said, we'll have a whole different lineup of objects to show next time, and we'll just keep going along. So again, everybody have a great night, and thanks for joining us. We'll see you next time.